Hey guys, before we get into this video, you'll notice that only a few people are subscribed to my channel. So most people who actually watch my content aren't subscribed. So if you do me a huge favor, please subscribe before you get into this video, and I'd really appreciate that. Welcome to Khetz Tutorials, and in this video, I'll be continuing a topic which I started, finance, right? So this is a continuation of finance, grade 12 mathematics finance. And to start with, I'm just going to discuss this term here, which is hire purchase. Now, if you're going to buy an item which you can't afford immediately, whatever the item may be, it's usually applied to expensive items. So if you can't buy it, if you can cash it out, you basically can get this type of purchase, which is essentially a loan. So you first pay a deposit, then the price of the item will subtract that deposit, and you'll be left with a balance to pay. Now this balance, you'll be given an interest associated with that balance, which means you use the simple interest formula to find the actual amount that you're supposed to pay. So after getting this balance, so after subtracting your deposit from your stated price of the item, you get your balance, then you apply interest to that balance by using this formula, and this A would be the amount to be paid. So that is the amount which you should pay. So after doing that, basically have that amount. Now this amount is to be paid in installments, and you can simply divide the period that you're supposed to pay this in. So let's say you're expected to pay in a year, so basically you're going to divide this by 12. So basically pay in installments, and installments, if the installments are to be paid on a monthly basis, which is usually the case, and you're expected to pay in a year, then you just divide your amount by 12 to find the installment, or to find the amount which you actually pay per month. So that is it with regards to your hire purchase. I'm now going to move on to the main topic of today, or this video, and that would be the future value. So when I talk about the future value, now let's say that you want to have a certain amount when you retire. So we'd be talking about retirement annuities, or you basically just want to save, and you're paying equal amounts at equal intervals, right? Or basically you want to set up a sinking fund, which I talked about in the previous video. You'd basically use the future value, and its formula is as follows. So the future value formula looks something like this. And I'm just going to explain each item which is in this. So let's say you want to save. You want to have a certain amount in the future. This F would be that amount. So that would be your future amount. And this would be your monthly payment or your regular payment, right? And this is just the interest, and the interest takes into account the compounding. So that would be your effective interest rate, or basically just saying whatever interest percentage you have divided by the compounding period, just call it M. That would be your compounding period. And your N is the number of times that you're going to pay. So let's say your compounding period is monthly. So if you were to pay over 5 years, there are 12 times 5 payments, right? So the 5 would be the number of years, and this 12 would be the number of times per year, which means you actually pay 60 times. In that case, and this is just 1, the value 1. So now that we have all of that in place, here are a few things which you have to know. Now, this formula is used if payment is to be made a month after starting. So let's say you want to set up a retirement annuity, or you just want to save, and you're starting today. Your first payment would be a month from today. That is what this basically means. And another thing is that it is assumed that no interest is earned on the last payment. This basically means that if we have a timeline, and you should have a timeline in most of the cases, just so you see what's actually going on. Let's say we're supposed to have, let's say, 5 months or so. So let's say this is January 1st, and this would be February 1st. That would be March, April, May, and June. Now let's say we're supposed to start our payment here as the statement which I previously wrote dictates. Now you're going to make a payment here, and it's going to earn interest. And that is if we were to pay for 3 months. So this would be June 1st. So here we have interest earned. Over there we have interest earned. And that would conclude your 3 months. So you paid here, you paid here at the end of this, or the start of this month, or in a month from that time. You made a payment over there, and you made a payment over there, and you're supposed to make a payment over there. So it's like 4 months that you actually, so it's 4 payments, but here you don't have any interest. So if you're told that you're actually supposed to make payments for 4 months, or whatever period it may be, then the last, so from the start of this to the end of the month, let's say May, the end of May 31st, it would not earn any interest. That is what the statement basically means. So after your last payment, your amount doesn't earn any interest, right? That is what that means. So we can also move on to say that since we know that the normal formula of our future value is effective, or it works when we are supposed to pay a month after we actually started, then what happens if we expected to pay immediately? Now for immediate payments, this is what would happen. You have January 1st, and you expected to pay here, expected to pay there, expected to pay there, and over there, let's say you don't have to pay. Let's say it looks something like this. So you actually pay at the start of the period in this case. So you pay there, pay the beginning of that month, beginning of that month. Now, what you're gonna have here is that you're actually supposed to earn interest. So this would be February, March, April. So over there, you're actually gonna have some interest. So after your last payment, you're gonna earn some interest because your payment is at the start of the period. And this is how you compensate for it in terms of the formula. So you're gonna have your future value formula, the normal formula, which I just showed you now. You're gonna have that as your formula. And to explain what I mean by this, I'm just going to do an example after this. So this is your normal future value formula, but this one, you'd have made a payment there and you make a payment there, and here you would not earn any interest. Now, if the payment is required to be at the start of the period, then let's say you actually pay on the 1st of January, or your last payment is on the 1st of January. So from that first day of January to the 31st, which is the last day, even though this point was your final point of making the payment, your money will still earn interest until the end of that month, even though your last payment was on the 1st, which is the starting. So this is an immediate payment, or payment at the start of the period. Now, to compensate for this, you basically multiply this formula by another period. So you take into account the compounding, of course, when you write that I, and after getting the value f, you just multiply your f by another period to indicate one extra month where the amount actually earns interest. So I talked about immediate payments, I talked about how the normal future value formula works, and I talked about where you'd actually apply this kind of stuff. Now, here's another thing which you have to know. So, an important point, the interest has to be compounded at the same rate as the payment. For example, just to explain what this means. So, example, let's say you're given an interest of 6% per annum compounded quarterly, and the payments are made each month. So monthly, you're dealing with monthly payments. So you can't basically just substitute this interest formula into the future value formula, because that is essentially not correct. You're supposed to have this compounding period match your frequency of payment, which in this case is monthly. And so what you do to transform your quarterly interest rate into those monthly payments, or to transform it to match the monthly payments. So we now want to transform the interest rate compounded quarterly into an interest rate compounded monthly, so it matches the payments. So this is the formula that you basically use. And I new would be your new interest rate, which you want to convert to. In our case, we want to convert to a monthly interest rate. And your I norm would be the one which you currently have. And so for our case, we want to transform a quarterly interest rate into a monthly interest rate. So substituting your values, you'd have this divided by 12 to the power 12. This is what you want to convert to, equals to what you already have, which is 6% compounded quarterly. Now all that's left is just basically to do the math, and the answer which you should get, you can just test yourself. The answer which you expect in this case should be 5.97% per annum compounded monthly. Now this would be the actual percentage that you'd use in the formula, because we want our compounding period to match the regularity or the frequency of payments. So those are a few things which I wanted to put out of the way. And before I do an example, I just want to talk about a few more things. The first being that, so let's scroll up some more. The first being that if payments can't be made for whatever reason, right, then interest is still earned. Let's say you're having a bad time financially, or whatever the case may be. You're expected to make 60 payments and you end up only affording to make 58 payments. Now, for the remaining, because you already signed up for this plan, which was supposed to give you a certain amount after 60 payments, you are going to use the future value formula, for example, using the 58, right? Using that 58. And after finding that value, so the value that you get after 58 payments for your future value, you actually apply compounding to that for the period which remains. And in this case, it would be 2 months, right? So you basically just make sure that it earns interest for the months that actually remain. And that is basically it. So you're left with 2 months, and you're supposed to make sure that it earns interest for those 2 months, even though you aren't making payments for the extra 2 months, right? And another thing which I want to touch up on is what we call deferred payments. Deferred payments. Now, when we talk about deferred payments, usually, as I previously stated, you pay a month after starting a plan, right? Let's say the plan is a retirement annuity, whatever the case may be. Expected to pay a month. So if you start here, expected to pay at time 1, a month later, right? But if you decide, or if the plan says that you're actually gonna pay, let's say for example 4 months later, then this is what you're basically gonna have. So your timeline would look something like this. If we are talking about January 1st and we move on to the 31st of the next month, the 28th of February, and move on to the 31st of the next month until the 30th of April. Now you're gonna skip that, and your payment is only going to start here. So 1, 2, 3, 4 months. So payment is only going to start 4 months later. Now this is what you do. To compensate for this, in your future value formula, you're gonna say the month skipped subtract 1, right, is equals to the value to be subtracted from n. So let's say in our future value formula, we were supposed to substitute n as 60 for 60 payments. Now we're going to say 60 subtract this value over here. So in our case, it's 4 months. So we expect this to be monthly, expect it to be compounded monthly as well. And that 60 will be coming from 12 multiplied by 5 for 5 years. So we want a future value for 5 years, but we only started paying 4 months later after starting the plan. So to get the same amount that we wanted to get, or we basically have to subtract this value, which is 4 months, subtract 1, which is equal to 3. So we are going to subtract 3 from our n and actually substitute it like that. So the value to be subtracted is the number of months skipped, subtract 1. So that is just a rule. You don't subtract the exact 4 from that total amount of time that you're actually supposed to pay. You subtract the months skipped, subtract 1. and that is why I subtract 3 in that case. Now, I already talked about payments made at the beginning of the period, and yeah, so usually interest is earned for one period less than the number of payments, and that is the usual case. And for payments made at the beginning of the period, then you just multiply the future value by another period of interest, which I just showed you. So now, just to sum up everything which I have been talking about, I just want to do this example over here. It says Tandile plans to retire in 10 years' time. It's calculated that he needs an amount equivalent to the buying power of R1,000,000 of today's rands. He expects, this should be expects, if I can just fix that quickly. He expects inflation to be 4.5% per annum for each of the 10 years. What amount does he need to have in his account in 10 years' time? So here's what you have to note here. The statement says the buying power, of R1,000,000. So if you recall, over the years, certain things actually appreciate, or they actually increase in value. So you can't expect the price of bread to be the same in 10 years' time, because there is inflation, right? So this R1,000,000 is of today's buying power, but he still wants to have the same value in 10 years' time. So for that R1,000,000 to have the same value in 10 years' time, we also have to inflate it, or we also have to grow it according to the country's inflation rate, right? So the first question is asking, what amount does he need to have in his account in 10 years' time? That is what the question is asking for. The question is asking for the value in the future that would be equal to R1,000,000 now. So now it's R1,000,000, but in the future, we have to have more than R1,000,000 to be able to buy what R1,000,000 bought previously. So that is what that means. So our principal amount would be that R1,000,000, and it is said that we have that as our interest. So it's 4.5% per annum, and we are gonna have that over 10 years. So the inflation over 10 years of that amount would lead us to this amount. So you can read this as saying, in 10 years' time, what R1,000,000 can buy now, in the future, you'd have to have 1,552,969.42 to buy the same thing, right? So that is question 1. We've answered question 1. Now the second question says it plans to make equal monthly payments for the next 10 years, starting in a month's time, into an account paying 9.9% interest per annum compounded monthly. How much are his monthly installments? Now it says in a month's time, which is the usual time that you actually pay. So don't take that as a deferred payment. You usually start so in this case, we want to have a certain amount in the future. So we should be thinking about the future value. So now that we already identified that we should have a future value, right? We are actually gonna, so we have the F that we should have in 10 years' time, which is the one which you calculated in question 1. Now we want to see what should we actually put, or what should we pay each month to have this value over here. And that monthly installment would be your X. So that is your monthly installment. So let's manipulate this formula so we actually have X on its own. So X would be equals to F multiplied by I divided by this whole bracket of 1 plus I to the power n subtract 1. And then we're going to substitute the appropriate values. So your F would be the value which you got in the previous question. So just copy this value and have it as your F. And your I should be, so the interest rate is 9.9%. and it's compounded monthly. That's why we divide by 12. And we're going to have 1 plus the same thing, which is I divided by 12 to the power 12 multiplied by 10 to indicate the number of payments that you're going to make. So since it's compounded monthly, in 10 years, you're going to pay 120 times, because in a year you have 12 months. So in 10 years, you expect to have made 120 payments. So now putting this into your calculator, you should get the monthly installment that you should put to get that value. And your monthly installment should be this, which is 7,624.71 cents. So that is all I wanted to talk about in this video. If anything wasn't clear, please let me know in the comments. If you haven't subscribed, please subscribe. And if you like the video, give it a thumbs up. And please communicate. I'll leave my email in the description, I think. If not, you just leave a comment. And I hope you learned something in this video. I will see you guys next time. I still have a few more things to discuss in terms of finance.